I'm John Peng from Uber. Today, I'm going to share some lessons and pain points for building a large repository with Bazel. So what the large repository mean to us? We have a repository that hosts almost all Go code in Uber. In order to limit the size, we do not check in the generated code, third-party libraries, and large files. But still, we have over 300,000 Go files, over 100,000 IDL files, importing 2,000 external Go libraries, and receiving 5,000 commits per week. So building this with Bazel, we get over 180,000 Go targets together with tens of thousands code generation targets. So what are our lessons and pain points? First lesson I want to share is CI at scale is actually pretty flaky. Our CI has to verify thousands of changes a day. And with this scale, we will run into out-of-memory issues on some CI nodes, remote cache issues, flaky tests, and issues downloading external repositories. And because each CI job has many shards, and some of the CI jobs have even 100, 200 shards, any of the shards fail will cause the whole CI job to fail. And because of this scale, it's really highly likely that one of the shards will run into these issues. So our CI job frequently hit into these issues, not related to the change. So what do? We wrote the Bazel wrapper to automatically retry CI when it catches one of these issues. So for remote cache issues, it simply retry with the same parameter. And because of the warm cache, those retry are actually pretty fast. And it will pick up where it left off. For flaky tests, we have a slightly different strategy because we don't want to retry a test that's already taking 15 minutes to fail. So we actually intercept the flaky test attempt and only retry the test that's not so slow to run. For out-of-memory issues, we know that some targets, they need more memory than other targets. So we want to reduce the number of concurrent jobs. So we progressively adjust the jobs parameter as a factor of host ran. And for Go module downloading issues, we basically set the Go proxy to the same proxy server several times. So in effect, Go toolchain will retry. The pain points, it turned out that it's hard to catch these issues. So as you can see there, for out-of-memory issues, there can be 3 different exit code. And for remote cache issue, there are 2 different exit code. And we also found that the exit code 1 is everywhere. It can be legitimate build issues. It can be out-of-memory issues. It can be remote cache timeout or build without bias misses. So we largely rely on passing the error message from build events. But this is not a long-term solution because the error message is not a public API from Bazel. Bazel can change the error message at any time in any release, and our CI will silently stop retrying. The next lesson we want to share is avoid downloading many repos at once. So what do we want to do that? Our CI is running on cloud. And for the CI cluster, there's always new machines join the cluster. And if that new machine happen to assign to a shard that needs to run the change target calculation, or happen to need to build a lot of targets at once, then it will have to download all the repos at once. And because of different repositories are downloaded from different services, and different services have their different SLAs, visibility to a CI cluster. It's hard to optimize every service to be performant and reliable. And on the other hand, when we are having to download thousands of repos at once, any of the download fail, it will cause the whole build or query to fail. So what do? First thing we do is to disallow Git repository rules and replacing with the more cache-friendly HTTP archive. And then we set up a periodic CI job to populate all these common cache directories, and then package each of them as a single archive to a blob storage. And then when there's new machine join the CI cluster, the first thing we do is to download all of these archives and expand it into their corresponding cache directories before running any Bazel command. So now our problem becomes from downloading thousands of repos from different services into downloading a handful of large archive from one single blob storage. This is much easier problem to optimize. And the pain point is, it turns out that Docker pools rule is not thread safe when the Docker repo cache is set. Other lessons, we found that people often forgot to update SHA-256 when they are upgrading the external repository rules. And when this happens, Bazel by default fetch the repository cache with the SHA-256. And then on a machine where the repository cache is available, then Bazel will fetch the old repo. When it's not available, then Bazel downloads the new repository archive, and then it causes the SHA mismatch. So we contribute a new flag to Bazel to ask Bazel to use the URL as the ID so that it always fetch the new archive. We also found that many tests can access the temp directory concurrently. And some of them are writing it, some of them are reading it, and this causes risk conditions. So we make all the common temp directories tempfs so that each test will have its own view of the temp directory, achieving better test isolation. Other pain points, one is that the proto-compiler flag from Bazel is actually not available to the Starlock rules. So if we want to use a different proto-compiler that's other than the default compiler from RulesGo, we will have to maintain the internal patch to RulesGo. And a lot of people already mentioned that the default proto-compiler often recompiles from the source, which is slowed down. And so we actually want to have a pre-compiled proto-compiler. The second pain point we want to share here is there's Bazel doesn't provide the target hash the way that Bach does. So if we want to check to see what targets a specific change affects, we will have to develop a tool or use one of the open source tools to run it outside Bazel. And this causes duplication of efforts. Hope these lessons help, and let's fix the pain points together. Thank you.